Why, hello everybody. This is That Programming Guy, and remember, you guys can do the thing no matter what you're doing, no matter what's going on. I believe you guys can get it done. So how is everyone doing today? Today we're fucking awesome like every other goddamn fucking week. We're all awesome. You know that. We guys are cool. Yeah. Anyway, yesterday I worked with Asmodan and we got some more Hangman done. On the morning of yesterday I did some Haskell programming. Today is more 68K programming. You guys guessed it. It is Sunday, so that means there is some 68K programming. So what did we get done yesterday? Yesterday, let's move that out of the way. Not yesterday, last week. We were like, alright, so we have the convert to binary, and we have convert instruction to binary. So basically we have all the four things: convert special operation specifiers, convert immediate or source EA, get binary from op mode. Oh yeah, convert destination EA. This is the stuff we need to call so we can get the correct instruction. Thingamabobber. So we did most of it. And now we have this. So if the source is... So now we're working on that. We're continuing that for the add instruction. I'll probably need to either use an interface to make sure each... Well, I would like to use an interface, right? The interface would be a great idea. Because I could say, convert immediate or source EA, convert destination EA. I could have all of these convert instruction to binary. I could have all of these methods, but then they'd be public. Which, I mean, I guess they could be public, but I don't need them to be public. That's the thing. I don't need these to be public. I only need, everything else needs to be private. And I can't make a private method from an interface method. However, each instruction will have to be executed differently. So probably having these as interface methods might be the best idea, since every instruction will have to probably process this differently. That's my guess. I have no idea if I'm right, but we're going to stick with it. Sleeping sounds really good right now. I like sleeping. Do you guys like sleeping? I've had a bad time sleeping recently. It's not fun. Oh well, that's what coffee's for. So now we're here. If the source is the data register, then the destination is the EA. Otherwise, we have to convert the source EA, which is here. Where are you? Oh, I have to give it instruction parts, huh? I can do that. There we go. Convert immediate or source EA. So basically, if we have an immediate number, okay, sorry. I just got done with the Python. I'm like, shit. How do we comment? Fuck. If source is immediate, no, that's spelled extremely incorrectly. Wait, what? Grandmaster Player 3. What's up? How you doing? Okay. Oh, that's funny. Alright. Thank you for joining me, Mr. Grandmaster Player 3. Yes, that's me. I'm Active Fireball. You know that. Stop drinking. Speaking of alcohol, what are you drinking today, good sir? Are you more wine, or did you purchase some rum? So we have so basically, if we're dealing with get the immediate number, rum. Well, I hope you enjoy it. You seem like a rum person since you always complain you're out of rum all the time. Int number. So if we have an immediate number, take off the hash, convert that to an int, and then we need to convert that to binary. Hey, KJ Miller, how you doing? You're off on Tuesdays, on Wednesdays, and Thursdays, so I left this one is after, and you need a lion. But why do I need a lion? And KJ Miller, thank you for joining me. Did you get enough sleep, KJ Miller? Don't kill yourself with projects. You're not young anymore. Go back to bed. Unless your daughter won't let you. I believe you have a daughter, right? Alright, so we get this, we get the immediate number, we convert it to an int. You're not even over 30 yet. Another month? Oh, so we're the same age. I didn't know that. I actually thought you were older than me. Whatever you say, Grandmaster Player 3. If you ship me a lion, I'll try to have one. How's that? Alright, so we have converted this to an int. This is going to be one word long. So a word is 16 bits. That's a 2-byte word. So basically, I need to convert 2 bytes. You're only 24? Good. Fucking great. You have your life in front of you. Can I convert this to an int 16? Whoa, I pressed a button. I pressed alt. That's what I pressed. Dot to int. Sweet, I can do it to int 16. Awesome. Int 16. Well, good for you, KJ Miller. You're getting shit done. All I'm doing is making an assembler for a computer chip that nobody uses. All right. Okay, this water is helping so much. This is great. So now we have this converted to an int 16. Now we need to convert this to binary. Can I do that? It is fun. I enjoy it. I'm doing it because I want to program for the Sega Genesis. The Sega Genesis is programmed, is using the 68K microprocessor. I'm like, well, looks like I gotta learn me some 68K. And then I'm like, well, what's the best way to learn assembly language? Let's make an assembler. By the way, KJ Miller, just to let you know, Grandmaster Player 3 is drunk, so that's why his questions are really weird. C# converts int 16 to binary. Right. It's in binary. I have to write it. Convert to string value. Okay. Convert to string. That's not what I want. What, are you not drunk, Mr. Grandmaster Player 3? Oh, God. Oh, to base? 2. I don't know. Does that work? No, damn it. Append. What? No. Yeah, okay, it's A. That's what it is. All right. Well, enjoy your rum, good sir. However, Grandmaster Player 3, you should get back into designing. Because that's what you want to do. Three or four projects you need to work on. That's a lot of projects. I only have like 3, I guess. I have my 68K, I have Haskell, and I have the other project, which is the subscription-based stuff. I also guess I have the one with Asmodan as well. I don't know. Okay, so if instruction. So basically, we're dealing with a hash. We have immediate. Otherwise, return. Right, the reason why I'm doing with the freaking casing is because of Python. Oh my god, switching from Python to C# is stupid. Oh. Okay, so now if we are dealing with the EA, oh, I have return null, so I don't even have anything to do yet. Okay. So if immediate or source EA, so we would have add dot B. I see. Well, you should focus on the stuff that gets you money. And the other stuff that makes you happy. Add dot B. By the way, you mentioned the thing about Ikigai. Like what? A year back? And actually I read about the Blue Zone. It's actually a really good book. It actually talks about that. No, I have not thought about Python. Is that like Python but in C? Add B. Oh, I need to get the effective address. So this would be something like EA D0. Interesting. Python, huh? C extension for Python? What? Python is an optimizing static compiler for both the Python programming language and the extended Python programming language based on Pyrex. It makes writing C extensions for Python as easy as Python itself. Python gives you the combined power of Python and C to let you write Python code that calls back and forth from C or C++. Easily tune readable Python code into plain C performance by adding static type declarations, also in Python. So use combined source code, let you debug and find bugs. That's interesting. No, I have not thought about Python because I didn't even know it existed. At the moment, it doesn't sound too interesting to me. But yeah. Actually, after Haskell, I'm gonna go to Rust. Because Rust sounds cool. Jython and I... What the hell? Jython is Python. Open source implementation of the Python programming language was slightly integrated. Seriously? That's kind of crazy. I don't know why it's called Iron, though. Like, too bad they couldn't do something like Python.net. Interesting. You know, that's actually, speaking of Iron Python, it reminds me a lot about PowerShell. Because PowerShell, you're actually able to access the .NET framework. So basically, you can just use the .NET in PowerShell, which is crazy. And that this reminds me of. That's really interesting. I didn't know Python was so big like that. Of course, I never really programmed Python anyway. PyNet rhymes with Skynet. Shit. Well, never mind then. So we have EA, we have an effective address, right? So we have things like page this is on. EA, which is that. Addressing mode, DN mode, and 16. It's multiple words from 1 to 6 words, I believe. So what, we're on, what page are we on? 4, 5, thanks. If you go up to 2. No, that's the conditional code register. Let's go all the way back up here. There we go. Instruction format. That's what we're looking for. So we have the single effective, single operand, immediate operand, or source effective address extension, if any, 1 to 6 words. So EA for source is 1 to 6 words. So this is the fun part. 4, 5, right? Too far. Alright, thanks for letting me know. Have fun with your lurks, and I hope the editing goes smoothly. The editing sucks sometimes. Add. So, now this is when I'm going to read this, and I have to figure it out. So it means that I'm going to have to... Instruction parts is... EA. Yep, I totally get that. Editing my own stuff sucks. Okay, so, oh my god, that water has helped so much. It's been great. Alright, so EA could be literally any of these for the source right now. So I would have to write down... Oh god, what would I have to write down? It's 16 bytes, 16 bits, right? Oh, boy, I actually never thought about this before. So let's say they do AN that, right? And I see this, so it means I would see... what would I see? If I saw AN, I'd see A2 star, right? Mode is equal to, I don't know, 001. This is 2, so register is equal 012, 010. So that's 6 bytes, 6 bits. I need another 10. Is that just what I do? Just mode register and that's it? I think that's what I would do. Sign extended. So if we go to here, instruction format. No, bastard. That's what I want. Yeah, if any 1 to 6 words. So I see. Oh, I get it. Single effective address. Okay, it is like, it's the register and mode and then just X's. So 00000. So yeah, if I did A2 star, it would be the register, which is 010. It would be the mode, which is 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, that's how it would look. And I have a viewer that's coming up, and that's fine. All right. So that makes sense. So I'm looking at here to figure out what I need to do. So if they were like... So now I had the D16AN, right? Because that's one I can use, right? I need to stop switching between these. go back up here. I can just go back to look. Da 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 da. Come on, I need to get to chapter 2. Alright, this is a bit too far from what I'm looking for. Where is D16? No. 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 D16AN right here. So the address register, which is 0 to 31. So we get the effective address. Oh, shit. We're not doing multi. Hello, Moon Man. Thank you so very much for joining me today. How are you doing? EA mode field and register field is 101. So if the register is first, then it's the mode, M-O-D-E. I see, the D16 is the displacement. 16-bit displacement. Getting ready for a... Are you going to do another dance battle? Did you learn how to do a backflip yet for the dance battle? Assuming you're doing one? Ow. Okay, so that's the displacement. So now that we have that going, let's look back up here. Aha, displacement. 0, 1, 2, 3, 4, 5, 6, 7. This is a 16? D16? Oh, base displacement, out displacement. I get it, okay. What language? You don't plan these. I am doing actually 68K, so for the Motorola 68,000 microprocessor. And the reason... Oh, Junkie! I know you. Hello, Junkie. Haha. To give you a background into why I'm doing this, why the hell I'd want to do freaking assembly language, is because way back, I'm like, I want to learn different languages to better myself. So I made, as a base, I actually made a maze generator in C#. So let me actually show you. There we go. So there's a book called Mazes for Programmers, which is actually a really fun book. It's basically this guy, and he talks about like how to make mazes, you know, with programming. It's really cool. I have it. So I'm like, you know what I want to do? I want to make my own mazes. So this is a maze generated with a binary algorithm. It looks really fancy. So I wanted to use Haskell, and I wanted to learn Rust. So I was like, let's make a project in Haskell. Let's make a maze generator in Haskell and a maze generator in Rust. Haven't done Rust yet. So I first made one in C# so I can get the base idea of how to do it, and then move into Haskell and also do it in Rust. So that's why I'm doing the Haskell project. Now, why I'm learning 68K programming? Well, it's because I also wanted to make a maze generator like this with the Sega Genesis. So the Sega Genesis uses the Motorola 68,000 processor. So in order to program for that processor, I would have to learn assembly. However, instead of just beating my head against the wall and learning assembly, I'm like, you know what? The best way to learn this language is to make an assembler and an emulator. So that's actually what I'm doing right now. I am making an 68K thousand assembler and a 68K emulator to learn assembly. So yeah, it'll be fun. I love it. It's great. So this is a full extension word format because my base displacement is 16. So this would be, I guess, 0 through everything? You don't plan these? I see. So what kind of battle is it then, Boon Man? If you know. IS 000 scale. Yeah, displacement and scale. Which is interesting. Address in direct mode. Yeah, sign. Yeah, so sign extended. SIGNEXTN did INTGR, and it's a displacement. This is really interesting. So what is it? What is a sign extended integer? Sign extension is the operation computer arithmetic to increase the number of bits of a binary number while preserving the number sign of the value. It's done by appending digits to the most significant side of the number. Following procedure depend on. Okay, yeah, that makes sense. All right. How long? 26 minutes. Okay. Cool. I can do that. So if I'm given a 16-bit number and I want to extend it to number of extension words, 1. In the address register indirect. So what I'm doing right now is I need to take the memory accessor, so the effective address, and turn it into binary. Oopsies, sorry. Turn it into binary. So I know how to do like 1 or 2 of them, but like this one, this is saying take the memory, take the address that's in this address register, add this 16-bit decimal to it, and then we get the pointer to in memory where we need to go. So I'm figuring out how to take this and turn it into binary so the emulator can understand it. Now, because I'm making my own assembler and I'm making my own emulator, I can kind of do what I want, but I also want to, kind of follow the manual so it's more cohesive and it's more comes together. That's what I'm doing. So, yeah. Well, Moon Man, I'd like to see the video of this battle whenever it happens. Sonic Sun and 16-bit displacement ninja in the extension word. Okay, so this is an extension word. EXTENSIONWORD. Displacements are always sign extended to 32 bits prior to being used in the effective address calculations. Oh, I get it. So it's 16 bits, but it's sign extended to use. Okay. Stays as 16 bits. Sign extended when used. Yay! Alright. So now, if we go all the way back up here. 1 second. Sorry. Alright, so I have a 16-bit displacement. So I think it would be the base displacement, because it's 16 bits and the displacement here is only for 8. So I think it would be this. It would be 0, 0, 0 for everything. And then it would be the base displacement. Brief extension word format. Well. Use the brief extension and address register indirect with index 8-bit displacement mode. Oh, this is what I'm looking for. That's fine. Whoa, I can't read this. Right, phone, that's fine. Alright, everyone. Well, it is 30 minutes past the hour. Guys, Guys, to all my wonderful lurkers and watchers, do you want to be fucking awesome? Do you want to support this channel? Do you guys need more shirts? Yes, you do. You gotta go. Have a good swim. Alright, Moon Man. Thank you for joining me. Do you guys need more shirts? Of course you need more shirts. That's a stupid question. Do you want a shirt that's better than Fruit of the Loom? That's higher quality? That feels better? Do you want a shirt that shows other people that they can do the thing? If so, I have the perfect shirt for you guys. Damn it! Shirt, come here. Ugh. I have this alpaca fur shit. Can I do that? How much is this? Oh, it's a Kickstarter. Stop making this more difficult for me. Alpaca wool clothing. That is expensive. Well then, KJ Miller, don't buy my shirt then. Anyway, guys, you need an awesome shirt. You need a shirt by that programming guy that looks like this. Because you all need a fugly unicorn with the rainbow that says, remember, you can do the thing. These shirts are great. Only the best for my pod. These shirts are great. They're made with Gildan t-shirts. They're super high quality. They're uber comfortable. They look nice. And everyone who just sees them is so great. Because people just see the shirt and they're like, that's fucking great. So guys, if you're on YouTube, or if you're not, buying one of these shirts, programming guy, is super, super simple. Just go to www.thatprogrammingguy.com. You can either click on the hamburger and go to Merc, or you can go to click on the picture. I haven't changed this yet, so if you're watching this is still here, don't buy this test. Don't buy it. If you want a shirt, man, click on the shirt you want. You get from small, medium, large, extra large, 2X large, 3X large. What about the gals? The gals have shirts too. Gals have shirts too. Boom. Women's shirt. You can select your size. You can select your color. And guys, you want to see something that's cool? Let's say click on white. Magic. Anyway, these are so simple to buy. Go to www.thatprogrammingguy.com. Pick the shirt you want. The quantity you want it in, press add to cart, boom, you can then go to your cart symbol, you can purchase a shirt, $40 per shirt, no shipping is done, fuck shipping, you don't have to pay for that shit. Gals have shirts too. I like that idea. Oh my god, actually that would be a really good idea for that program, for a Active Fireball shirt. Girls have shirts too. Anyway, guys, if you want to support me, if you want a really great looking shirt, high quality shirt, because I'm not going to sell you Fruit of the Loom, consider buying one of these shirts. It's fucking great. And if you don't, that's fine. Just continue to watch me on Twitch and YouTube, because that's also really cool. Alright, that is my ads for the day. The syntax of movie instruction, for example, is movie EAAN, which tells us that the source is one of the 14 possible combinations present here, while the destination of one of the address registers. Yes, KJ Miller, you are correct. They are not made of Peruvian alpaca fur. I'm sorry. Strictly speaking, however, the syntax in the instruction is move EA E1 E2, where EA1 can be one of the 14 modes. The addressing mode is encoded using 3 fields of the binary instruction: the EA mode field, the EA register field, and the extension words. The first 2 are 3-bit fields, yes. The extension word instead are words that follow the instruction word in memory, and that usually represent the actual 8, 16, or 32-bit numbers. No. Oh, wow. Oh, wow. He's actually providing stuff. This is great. With post increment. I mean, this is really hard to read, but it's really cool. All right, here we go. The natural evolution previous to adjustment modes is an arbitrary offset that is added to the base address. The standard syntax for this mode is that 16-bit signed integer. So, for example, OXFA1 is the data contained in memory address A1 plus OXF. The EA mode field is 1-to-1. Register field is in the register field. The address mode requires one extension word that contains the 16-bit displacement. Please note the displacement is fixed to 16 bits, so its value is limited to the range that. The displacement is, however, assigned extended to 30 bits before being added. Okay, so you don't tell me how it's actually written down in binary. Alright, then I'm just gonna have to make a guess and just do something and figure it out as I go along, because fuck this shit. So I'm gonna have, let's say I have D16A2. Then we have the register, which is 0, 1, 2. We have the mode, which I think is 1, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have the first word, which is probably this. This is the register, but no mode. So then I think it's just a word. And so it's like 16, so what can I fit in 16 bits? 2 bytes. 7, 1, 3, 2. This is a bad idea. You know what? Fuck this shit. Haha! Decimal to binary. I'm not gonna try to write that down. 7132. Convert. This is 1, 2, 3, 4, 5, 6. Oh my god. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, cool. So we have 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 0, 0. That's how it would look. Cool. Great. Wonderful. That's how it look. I got it. Cool. So we're just going to deal with this. We're going to have some fun. So, if the source is immediate, we need to get the addressing mode, and we need to be able to convert it to the binary that we need. That's what we need. Yeah. So, we have effective addresses. Sorry, we have addressing modes. This is the one we need. Oh, we get to use this, guys. We get to use this thing I made. So basically, let's say we're given add byte 7132 A2 D4. I don't know. This is we're gonna have to worry about. Is it? Hold on. What's the assembler syntax for this thing? Assembler syntax. Just D16AN. Alright. Cool. How do I know in here? Because there's D8 and D16, right? Oh, where's the D8? Hold on. Don't I have the addressing mode for D8? Hold on, what's going on? Did I mess something up somewhere? No. Where is it? Oh, I know what to do. Let's go to add. Add Q, add I, add I, add A, add A, add. Oh, that's how. If it's a D8, there's 3 in here. Oh, that's fine. All right, so we have this, which is 7132A2. So we're doing with the 16-bit. So we're gonna call. So we need to go make the addressing modes. So addressing modes equals new. Probably not the best way to do this. That's fine. Addressing modes dot get addressing mode using the effective address. So this is 0, this is 1, this is 2. Instruction parts 2. There we go. And this is going to return an effective address. Effective address. There we go. So now we have this effective address, and my bladder's like, yo, you've drinking a good amount of water. You should go to the bathroom. But no, I don't want to go to the bathroom, buddy. Fuck you. What does people on my phone want? My phone's been blowing up. I have a Gmail and I have a Twitch. Not all right, and oh, she's streaming. Yay, her. Okay. So now with the effective address, which basically returns this, which is cool and all. So now I need to take the effective address. So I need to take the effective address, which is the mode and the register. I need to take 7132A2, and I need to combine those to make that. No, not that. Sorry, I need to make that. Yeah, this one. You can totally understand my writing, can't you guys? All right, so we need to now combine these two. To get the binary. I think, oh my god, okay guys. To anyone new who is like new to object-oriented programming, I guess this is in other things as well, like C with procedural. But one of the big things with object-oriented programming is that you get the question of where is the best place to put this? Because I am now having to deal with the effective address, and I'm also having to deal with a string and putting the two together. Almost like zipping the two together to get me a binary string. Right? So it can't really go into the add instruction because this logic needs to be generalized because everyone's going to use it. Real problems. Yeah. First world problems. God, this fucking awesome guy on Twitch is installing Peruvian alpaca shirts. He's so basic. Ugh. And also object-oriented problems. So that's going to be so my first thought was to put it in the effective address. However, this class, effective address, oh, I know what it can do. This class, effective address, is just to use to hold this information. That's it. It's just to use to hold this information. It's not a conversion though. I could put it under common and put it under its own class. That would be really interesting, wouldn't it? Always put it the closest thing? Yeah. But, I mean, I could just be fucking lazy. But, I mean, that is a good rule in general in programming. Is just be like... Alright, public... Combine EA... EA... And... IN... Oh, right. Oh, yeah, duh, I'm a dumbass. Oh, I'm a dumbass. Yeah, this is gonna be an instant method, not a static method. I'm thinking in Python now. God damn it. You're so correct, because I have access to the mode and register. So I'm a dumbass, I think. Alright. There we go. String instruction. Public. String. There we go. What's pylon? Because my first thought is a pylon for Protoss. Oh yeah, composition over inheritance. Oh, is a big thing. Like I have, oh my god, PyCon. Okay. No, there are so many videos that say go use composition over inheritance, and the big reason why, for all you people who don't know this, is let's say I have an inheritance tree like even like 1 or 2 layers deep. If I change one thing in one of my base classes, that means everything else under me also has to change, which is crazy. But yeah, everyone's always like, yeah, composition over inheritance, always. But I think for a fun little project like this, that's fine. I think if I keep doing this and finish this, it will be a neat idea to change it to composition to see the differences. We're gonna return null here, because I don't want to deal with it right now. So combine EA and instruction. So I'm gonna have... No, I'm gonna need the syntax, aren't I? No, wait, hold on. Right, get addressing mode changes the instruction into this, and we get that. Okay, I get it. So I'm gonna have to do a simple like, if 0, 0, 0, do this. If 0, 0, 1, do this. If 1, 0, 0, do this. Okay, I get it. So, if 0, 0, 0, return the register, which is the register, the mode, and then 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Cool, I think that works. You know, another idea. That'd be a cool idea, but that's fine right now. Alright, so I'm gonna do this. Is gonna be fun. If this dot mode is equal to, and to all you watching, string comparisons are fugly and slow and stupid. Don't use them, but I'm gonna use them because this is gonna be a first. This is me grade like V0.5, so I don't care. So if mode return 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus this dot mode, plus this dot register. Boom, done. Simple, great. What's the next one? 0, 0, 1. Technically, I guess I could do if convert this mode to an integer equals 0, 1, 2, and 3. I could do that if I want to, but I don't know if the extra conversion would actually make this slower or not. Else, if this dot mode is equal to 0, 0, 1. Yes, Tyranny? What? I don't know. Are you dressed? Yeah. Okay. Did you? You did. You want to say hi to people?
Hi, people.
Thank you, sweetie. All right, so next is this. It's 0, 0, 1. It's the same thing. Okay, so I can do this. If mode or this dot mode is equal to. So from helping Asmodan yesterday, I've really seen that the logical comparisons for while and for and stuff like that are really confusing. I totally get where he was coming from, because I was like, here's a test and here's another test, but it doesn't look like this test. I totally get it. So I'm gonna have to make sure to emphasize and help with that when I start my subscription service. I mean, KJ Miller, you can also try to start selling shirts as well. Alright, so that's fun. If 010. Yes, it was. I knew when I first started learning Boolean logic, I was also like uber confused. And it took me a while to understand why it was happening, because it's a jump in logic, you know, with Boolean logic, with Boolean arithmetic, it's like, what is doing this? So yeah, realized I should have gone better at it. Good for me to know. Yeah, I'll get better at it. Alright, so if... Well, I mean, all the other languages are truthful as well. And you also want to stay as truthful as possible, because you don't want to reverse things. Do I have that? Do I have that book? Hold on, I want to read you something. Alright, there it is. Ugh. I want to read you guys something. So this is from Code Complete. I actually read this whole entire book. It's a good book to read. Would I read it again? Maybe. Because there is a great sentence about Booleans. Aha! 431 is what I'm looking for, I think. Because, yeah, basically use an example of why everything should be as simple as possible. If I can find it. Ah, yes, okay. So, here is the sentence. Page 435. Forming Boolean expressions positively. This is to try to make your Boolean expressions not confusing as fuck. Not a few people don't have not any trouble understanding a non-short string of non-positives. Let me read that again. Not a few people don't have not any trouble understanding a non-short string of non-positives. That is, most people have trouble understanding a lot of negatives. Make your tests truthful, damn it. It's easier to read, both in English and with code as well. So if it's 010, we have address indirect. And so with address indirect, we have address register indirect mode. Oh, that's it? In the address register indirect mode, the operand is in memory. The effective address field specifies the address register can... Oh, so what should I do here? EA equals the AN. So the mode and the register. And that's it. Alright. So again, it's the same thing. Cool. That's 2. 0, 1, 2, 3. If you're 3, now we're getting into some fun stuff here. If it's 3, more. You want more? Yes, sir. All right. You can have more. Oh, boy. We take the contents. We add it to the operand length. And of the operand pointer. So of the operand length. Huh. Is this... How would I do that? Huh. All right. How would I do that? Where would that go? Yeah. Gotta be truthful, guys. Extensions. Index register type. Scale factor. 0, 1, 2, 4, and 8. So this is a scale. I get it. So for this one, so if we did like AN plus, right? You guys can't see that, can you? That's fine. AN plus. We'd have a size somewhere. So we would have the register, which is, if this is like A2 plus, I don't know, 4. B0, 1, 0, 1, 2, 3, what is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The next one would be the brief extension word form. So we wouldn't have a displacement, so that'd be 1, 2, 3, 4, 5, 6, 7, 8. We have another 0. Then we have the scale, which can either be 0, 0, 0, 1, 1, 0, or 1, 1. So if I did 4, that's 1, 2, 4. So it would be 1, 0. WL. Word, long word index size. Just 0. The register. Oh, unless it's just like this. Oh, is it just like this instead? So 1, 2, 3, 4, 5, 6, 7, 8, 0. Let's just have a 1, 1. W or L, which would be word, or this is a sign extended word. No, it is a long word. 0, I guess, for sign extended. Then we have the register, which would be 0, 1, 0. DA. This is the that. But there is no mode in here. That's actually quite interesting. I wonder if we need that. Well, anyway, guys, it is almost time to quit. I'm going to quit now. This is, I think, a good place to stop. What we did today was we started to kind of delve into the we basically started to delve into the, if we have the syntax, so like D16AN and a number like 7132A5, how we need to combine these two to get the binary instructions. So we did the data register, address register, and address register indirect. We did that. So now we're in the third one. So if we did address register with post increment mode and how we're going to deal with that. It's really fun going through the manuals. We actually had some people watch us today, which was great. So everyone, lurkers who are lurking, thank you so very much for lurking. Watchers who are watching, thank you so very much for watching. Bots who are botting, thank you so very much for botting. KJ Miller, I will see you next time as well. Guys, I'm on here every Saturday and Sunday at 11 in the morning. Saturday is Haskell, Sunday is 68K. If you're watching me on Twitter as a bot or something, give me a follow. I'd love to know what you guys like. If you guys are watching this on YouTube, give me a thumbs up, please. Give me a thumbs down if you hate what you see. In either case, give me a comment. Tell me what you like. Tell me what you hate. Subscribe, because when you subscribe, you are joining a family of other people who know that learning is hard and takes time. I might do some StarCraft 2 tonight. Otherwise, guys, I'll see you tomorrow bright and early at 8 o'clock for some Legend of Legaia tomorrow morning. I love you all, and I will see you all some other day.